Let us understand hypothesis testing. Hypothesis testing is a statistical procedure used for testing the statistical hypothesis. What is a statistical hypothesis? It is a conjecture about a population parameter. Now, this conjecture may be true or may not be true. It is simply a belief, a proposition, or a hunch, or a guess. We use this statistical procedure to determine whether this conjecture is true or not. We state it in form of a null hypothesis symbolized by H0 and the alternative hypothesis symbolized by H1. By convention, the equality sign is always considered as a part of the null hypothesis, and the inequality or the difference is part of alternative hypothesis. So null hypothesis says there is no difference between a specific value and a parameter, or in a two population case we may consider that the two parameters do not have any difference. Whereas the alternative hypothesis says that there is a difference from the specific value, or the two population parameters originating from two different populations have a difference. The researcher's claim can be about no difference, or it can be about having a difference. So researcher's claim can be null hypothesis or it can be alternative hypothesis. An example of null hypothesis can be that the average annual salary of a business analyst is $1 million. The alternate is it is not $1 million. Sometimes it may have a directionality that the average salary of business analyst is $1 million or more. In that case, the alternative hypothesis will be it is less than $1 million. Let's look at mathematically how do we represent it. When we do not make claim about the directionality, we state the null hypothesis with equality and the alternate hypothesis with inequality, and the significance level is split equally in the either tail of the normal distribution function. When we have a directionality in our proposition, we perform either a left-tailed test or a right-tailed test, and significance level in the tail alone is considered. When we do the hypothesis testing, since we are using the sample to look for the evidence for the proposition about the population parameter, there are two types of risks involved, or the errors that may occur. One of the errors that may occur is the true population parameter, though is true, does not get captured or does not surface in the sample collected. Typically, a sample collected gives you only a certain degree of confidence that it has captured the population parameter. So, let's say for convention we use 95% confidence level. So 95% of the time the sample will capture the population parameter. but there is a 5% risk that the population parameter is true but does not get captured within the interval band of the sample statistic. This error is called as the type 1 error, denoted by alpha, the significance level. On the other hand, it may be possible that the population parameter proposed to be equal to some value is not true. But because of the sampling process, we may mistakenly consider that we have the evidence of having captured the population parameter in the sample. This is the type 2 error, denoted by beta. Let us look at it in tabular form. There is a truth that we are trying to determine, the reality, and there is a sample data which is giving us the evidence in support or against the proposition. The confidence level will tell us whether the degree to which the reality is captured by the sample. It can show it in two fashions, that there is a population parameter and it is captured in the sample, and a certain value of population parameter is not true and it is not captured in the sample. But we may have what we call the type 1, it's also called as the false positive, and type 2, a false negative. What do we mean by false positive? Something which is true in reality gets rejected because of the sampling process. On the other hand, something which is not true in reality, but because of the sampling process, we believed it to be true. That's a false negative. So these are the two risks that we work with while doing our hypothesis testing. So some terminologies. What is a statistical test? A statistical test uses the data obtained from a sample to make a decision about whether the null hypothesis should be rejected. The numerical value obtained from a statistical test is called the test statistic. Type 1 error is the risk of rejecting the null hypothesis when it is true, and type 2 error when we do not reject the null hypothesis when it is false. At no instance we are saying that we are accepting a hypothesis, whether null or alternative. The reason is we cannot say whether we know the truth or not. All that we are saying is, do we have the evidence of a certain truth in the sample or not? As a matter of convention, we must know that what is alpha and what is beta, which represents the type 1 error and the type 2 error, the probabilities of those. So how do we perform these hypothesis testing? 1. State the hypothesis and identify the claim, whether it is alternative or the null. Given the standard error and the conjecture about the population parameter, we can determine the theoretical test statistic or the critical value at which it captures the 95% of the interval around it, or whatever the stated confidence level we have desired. Then we compute the test statistic value from the observed data. Once we have this theoretical and the observed statistic, we compare them to decide whether to reject or not reject the null hypothesis. Basis the rejection and not rejection of the null hypothesis, we can draw the inference about the population parameter. The inference is always stated in very specific technical wording. If the claim is H naught, the null hypothesis, and if there is no evidence to reject the claim in the sample, we say reject H naught. Or there is not enough evidence to reject the claim. We cannot equivalently say that not having enough evidence to reject the claim does not mean accepting the claim, because we can never make a statement about the reality. All that we are saying is, do we have evidence or we don't have evidence. If claim is H1, the alternative hypothesis, if there is enough evidence to support the claim, it means there is a difference in the parameter from the specific value, we reject H0. Or there is not enough evidence to reject the claim, then we do not reject the H0. We cannot say that we are accepting H1. Specifically, we perform or use the specific probability distribution function for the specific conditions in the data. So we have a z-test for the mean when the sample size is greater than 30 or the population is normally distributed, and we know the population standard deviation. The z value is determined by the sample mean minus the proposed or the conjectured population mean divided by sigma by root n. So this we determine from the sampling data, and we also determine it theoretically, which captures our confidence level equivalent area in the standard normal curve. In case any of these conditions are not met, we may use the t-test. We will use it when the population is normally distributed or approximately normally distributed. Sample size is not 30 and sigma is unknown. So we use the t-test and you compute the t statistic for n-1 degrees of freedom using the same formula as in z, except that the sigma is replaced by the standard deviation of the population of the sample. And we know that t distribution is a family of curve. For infinite degrees of freedom, it becomes normal. But practically, for a size greater than 30 or even close to 100, we see the values from the t statistic and the z statistic are one and same. We can also perform the z-test for the proportion, when we are assured that the observations are independent, both NP and NQ, which is the proportion multiplied by the sample size, and the complement of proportion multiplied by sample size is greater than equal to 5, and the sigma is known. So we can use the z-test for proportion. Similarly, a chi-square test is applied for the estimation of the variance as well.